All right, in this video, we're looking at some special equations. Let's look at example A here. We have x cubed minus 8x squared minus x plus 8 equals to 0. So this is a polynomial with 4 terms, and it's not quadratic in nature, so we have to try to think about how to solve it using perhaps factoring. So let's think about factoring by grouping. If I were to group the first 2 terms and then group the second 2 terms, let's see what I would get. I'd have x to the third minus 8x squared minus x plus 8. Well, in the first parenthesis here, I can pull out an x squared, and that'll leave me with just x to the first power minus 8. And then I'll have, in the second parenthesis, perhaps just a negative 1. And the reason why I'd want to pull out a negative 1 is because x minus 8 is very close to negative x plus 8. The only difference is the signs are opposite. So if I pull out a negative 1, I'll put a negative 1 out in front, and then I'll basically multiply or divide all the terms inside by that negative 1. So negative 1 divided into negative x will give you positive x, and then negative 1 into positive 8 will give you negative 8, and that'll all be equal to 0 afterwards. So we have a common factor in the 2 terms, right? So we can pull out an x minus 8 out in front, and that'll leave you with x squared minus 1 is equal to 0. And so now we have a factored polynomial on the left, and it's set equal to 0, which means that we can apply the 0 factor property. That means either x minus 8 is equal to 0, or x squared minus 1 is equal to 0. So of course, this equation will give us x equals to 8 on the left here, and the other one will give you x squared is equal to 1. And of course, what values do you square to get 1? Well, the answer is negative 1 and positive 1. So we have 3 solutions here. It looks like we have negative 1, 1, and 8 for the equation. All right, let's take a look at example B then. All right, for example B, it looks like we should pull everything over to one side and set the equation equal to 0. So I'm going to have 6x to the third plus 36x. I'm going to bring over the 2x squared and make it negative 2x squared on the left, and I'll bring over the positive 12, making it negative 12 on the left, and that'll be equal to 0. Then from here, we're going to try to factor by grouping again. So I'll group the first 2 terms and then the second 2 terms. So I'm going to group 6x to the third plus 36x in one parenthesis. And in the other parenthesis, I'll put minus 2x squared minus 12. From here, the first parenthesis has a common factor of 6x. So I'll pull out 6x outside, leaving me just x squared in the first term. And then 6 goes into 36 6 times, and the x has been taken outside. For the second parenthesis, I have a negative 2 that's common to both terms. So I'll pull out a negative 2. So negative 2 divided into negative 2x squared will give you just positive x squared left over. And negative 2 divided into negative 12 will give you positive 6. And that'll be equal to 0. From there, each of these terms has a common factor of x squared plus 6. So I'll pull out the x squared plus 6. And what's left over then is just the 6x minus 2. Now from here, we have a factored polynomial set equal to 0, so we can apply the 0 factor property. So we're going to have x squared plus 6 set equal to 0, and 6x minus 2 set equal to 0. So x squared plus 6 equals 0 means that x squared is equal to negative 6. And then we have 6x is equal to 2 on the other side. We can solve the one on the right pretty easily, divide both sides by 6, and we end up with the idea that x is equal to 2 over 6. And of course, that can be written as just 1/3. So that's one answer. Now for the other one, we have basically that x will be equal to plus or minus the square root of negative 6, right? Because in order to get rid of the square that's on the x, we take the square root of both sides. And that can be written as eventually x is equal to plus or minus I square roots of 6. So all I did is pull out the negative 1 there as an I. So we have 3 solutions again, which of course is appropriate for a polynomial that has degree 3. All right, so let's take a look at example C here. For example C, it looks like we might have just 2 terms in the problem, although they're very complicated terms. And it looks like there might be something actually in common between the 2 terms, namely this x squared plus 2x. The problem is what power do we pull out? Well, remember the rule is that we want to pull out the smallest power, right? Because we can't take more than something has to give. So we have x squared plus 2x to the 1/2 power. We can take that out because the other term has that much and more, right? It has x squared plus 2x to the 3/2 power. All right, so let's go ahead and pull out the x squared plus 2x to the 1/2 power. Let's pull that outside and see what results. Well, that would mean this is gone from this piece, just leaving 13x. We'd have minus 2, and we'd have something left over. The question is, what will be left over? Well, the rule is essentially that you're dividing when you're factoring, right? So that means I'd have to actually do x squared plus 2x to the 3/2 power, and I'd have to divide that by x squared plus 2x to the 1/2 power. So these are the same base. So what happens when two things have the same base? We keep the base and we subtract the exponent, right? So 3/2 minus 1/2. So 3/2 minus 1/2 actually ends up giving you 2/2, right, for the exponent, or in other words, just to the 1 power. So inside this parenthesis, what's going to be left after we factor is just x squared plus 2x to the 1 power. All right, from there you essentially have, so you essentially have two things that are multiplied and the result is 0. That means we can apply the zero factor property. So I'm going to set x squared plus 2x to the 1/2 power equal to 0, and I'm going to set 13x minus 2 times x squared plus 2x equal to 0. The one on the left can be solved by basically recognizing that if we square both sides, we'll remove that exponent, right? If we square both sides, we end up with x squared plus 2x. Remember that squaring the 1/2 there will cancel that out, and 0 squared on the other side is just 0. Then we can continue to solve this by basically factoring. We factor out an x, and we'll be left with x plus 2, and that'll be equal to 0. And then, of course, we can apply the zero factor property, right? So we'll have x is equal to 0, and x plus 2 is equal to 0, right? Because these two were multiplied, and they were equal to 0. So we separate them and set them equal to 0 separately. All right, so the first one is solved, x equals 0, and the second one gives us x is equal to -2. We're going to have to check those answers because we did square to solve the equation, and when you square, you might introduce answers that aren't actually valid. Let's solve the second one here. To solve the second one, we're going to basically distribute first. So we'll have 13x, the -2 will multiply by the x squared, and we'll have -2 times the +2 giving you -4x, and that will all be equal to 0. Then we can combine like terms, so we'll have -2x squared. Now 13x minus 4x is going to give you a +9x, and that's equal to 0. From there, we can go ahead and factor out an x, which is common to both terms. So we can factor out even -x for that matter. So we pull out -x, we're going to have a +2x left over, then -9 left over, and that'll be equal to 0. And then from there, we have a product that's equal to 0, so we can use the zero factor property, right? So we'll end up having -x is equal to 0, which is another way to just say x is equal to 0. And then we have 2x minus 9 is equal to 0. And that'll give us 2x is equal to 9, or in other words, x is equal to 9/2. Okay, so that was quite long, and we moved a little quick on it just to finish up the last bit of it. But there we have our solutions, x equals 0, x equals -2, and x equals 9/2. Now, as I mentioned before, we do need to check to see if x equals -2 is a valid solution. I think x equals 0 will work because it worked over here, and if it worked over here, then it doesn't matter if it came on the left-hand side over here from squaring, it probably will work. We didn't square for this equation. So let's just check x equals -2 in the original equation and see if it works. Okay, so I've just written our answers over here nice and neatly, and we're just going to check to see if -2 actually works, because that's the only one we really have to be worried about since it came from the process of squaring an equation to solve for the answer. So let's go ahead and plug in the -2. Well, one thing I just want to show you real quick is if I put -2 just into this part of the equation, it'll be -2 squared plus 2 times -2 raised to the 1/2 power, for example, right? Well, -2 squared is 4, and then this gives you -4. So inside this parenthesis, we end up having 0. Now remember, if that's 0, then so is this. This is also 0. And then taking the square root of 0 or raising 0 to the 3/2 power, that's also going to give you 0. And if those two terms are 0, because 2 times 0 is 0 and 13x times 0 is 0, you're going to end up getting 0, of course. So it looks like -2 does indeed check.